neighbors algorithm. Okay, this is also we are called as KNN algorithm. It is also called which one? KNN algorithm. Okay, so the nearest neighbors algorithm is also called which one? KNN algorithm. KNN stands for K nearest neighbors. K nearest neighbor is a full form of KN. So any machine learning algorithm, first we have to identify in which category that algorithm comes. Either it comes into a supervised learning, or it comes into unsupervised learning, or it comes into which one? Reinforcement learning. First you have to identify what is the type of that machine learning algorithm. So here the KNN algorithm is a type of supervised machine learning algorithm. That means it is a type of supervised machine algorithms. That's why the input data to this algorithm must be a which one? Label data. The input data to this algorithm must be which one? Label data. Label data means compulsory the data set must contains the class label. Contains which one? Class label. And the second point you have to identify this algorithm is applied for both classification regression, or is this algorithm applied only for classification regression. Then that point you have to uh, find out the next point. Here the KNN algorithm can be used for solving the both classification problems and for solving the which one? Regression problems. Here we have to keep in mind one point. Some of the algorithms are used for solving both classification and regression problems. Some of the algorithms are used for solving only regression problems. Some of the algorithms are used for solving only classification problems only. For example, let's take as nearest neighbors KNN algorithm. It is used for solving the both classification and regression problems. For example, if you take as logistic regression, that algorithm is used for solving only classification problems. Okay, you may get in the doubt why the logistic regression is used for classification. Later we will discuss. Okay, whereas linear regression is another type of machine learning algorithm. That linear regression machine learning algorithm is used for solving the regression problems. Clear? So that is second point you have to find out. Now in this algorithm, first one is it is a supervised learning algorithm. Second one is it is used for solving both classification and regression problems. Now we have to find out what is the value of k. What is the value of k? That means how many nearest neighbors are having. Okay, we have to find out. Based upon that k value only, we have to find the class of the given test instance. Okay. Now KNN is a non-parametric method. What does it means? It does not make any assumption on underlying the data. That means non-parametric method means we are not taking any mathematical assumptions, okay, for finding the class of the given test instance. Directly we are using the distance metric method. By using the distance metric method, we are find the class of the given test instance. Here we have to remember one more point in KNN algorithm is it is a lazy learning algorithm. It is a lazy learning algorithm. Okay, in many of the interviews, also in many of the campus placements, they are asking why the KNN is called as lazy learning algorithm. Okay, so why we are called as KNN is lazy learning algorithm means, so in general till now we are discussing in any machine learning algorithm we are taken as data set. To the data set we are applying the machine learning algorithm, then we have to get the model. Okay, but internally if we are talking about the if we are talking in depth about the KNN algorithm, but in actual scenarios we not get the exact model for KNN. Okay, so we are not find out any model, or we are not getting any model to the given data set if you are using the which one? KNN algorithm. We are just finding the distance from test point to all the points in the data set based upon the distance values only. we are find the class of the given test sample. Class of the which one? Given test sample. That's why we are called as which one? Lazy learning algorithm. Okay. So it does not learn from the training set immediately. Okay. It stores the data set, and at the time of classification, it performs action on the which one? Data set. That means at the time of the given test instance, at the time of the given test sample, it finds out the distance from the test point to all the points in the training set. By using the distance values only, we will find out the class of the given test sample. That's why this KNN algorithm we are called as a lazy learning algorithm. Let's see how it can works. Let assuming as before KNN we are having uh, class A points and also class B points. Okay, so we are having the dataset contains two different classes of points, class A points and class B points. For example, if I am given as some new point, okay, so we have to find out what is the class of this new point. This may be a class A point, or it belongs to which one? Class B point. So how we will find means, so we are finding distance from this new point to what are the points we are having in a training set. We have to find out distance from this point to this point, and this point to this point, this point to this point, and this point to this point, and from this point to this point, this point from test point to the this point. Like means we have to find out the distance from the test point to all the points in the data set. Okay, so after finding the distance from test point to all the points in the data set, based upon the value of k, okay, based upon the value of k, we can categorize the class of the given test point. For example, let's take some k equal to 3. K equal to 3. Okay, so from k equal to 3, that means we are taking as 3 smallest distance points. Okay, for example, first one is S class, for example A class. Okay, maybe next nearest distance may class belongs again A class. Next nearest distance class may be a B class. Is that having which class? A class. That's why this point may belongs to which one? Class A. Okay, so clearly you're understanding with some example in the next slide. Okay, so this is before applying the KN algorithm. After applying the KN algorithm, we can find the class of this test point. The class of this test point may be either class A or class B. How this class will be finding, we will discuss in the next slide with some example. Okay, let's see how the KN algorithm works. The first point to remember, the first point in KN algorithm is we have to choose a value for k. Choose a value of k. Then calculate the distance from the query point. Here the query point means test point. Query point means test point. That means to which point we want to calculating the class, that is we are called as a query point. For example, this is the which one? Query point. This is test point, or this is a query point. Okay, so that is the query point means to which point we want to calculate in the class, that is called which one? Query point. So from the query point to what are the points we are having in the data set, to all those data sets we are calculating the distance. Here we are using the distance method. Maybe a Euclidean distance or maybe a Manhattan distance. After calculating the distance, we have to select k nearest neighbors. K nearest neighbors. That means we have to choose k smallest distance points. We have to find out k smallest distance points from the training data, from the training set data set. So after finding the k nearest or k smallest distance points from the data set, from those k smallest points, each smallest point we have to find out the class. Okay, so from that class, which points are having the majority class, now that is the class of the given test points. So the query point based upon the majority vote, of the KNN for classification. Okay. For example, let's say k equal to 3. So first point is S class, second point is S class, third point is no class. Measured is S class. That's why the given test points belongs to which one? S class. That measured voting technique we are using for which one? Classification. Whereas in regression problem, okay, so we already know that k equal 3 means we have to pick the k smallest values, okay, points, okay. If you are applying regression problem, we have to find out the average of those k smallest distance values. We have to find out the average of those three smallest distance values. That is, we are using which one? Regression. First we will understand in the classification problem. Let's take as the data set contains 6 records. Okay, so here I'm taking as two different types of classes. The class may be apple class or orange class. Okay, to find out the class label, here I'm taking as two features. One thing is weight and texture. So if the weight of a fruit is 150 grams, a texture 0 means smooth, 1 means rough. If it is 0, it may be a apple. For example, if the weight is 160 grams, if it is a rough, okay, I can classify it as a which one? Orange. That is like that we have taken a sample data set. Okay, this is the given data set. So if I want to find out what is the class of 145 grams and smooth texture equal to 0, that means we have to find out, okay, what is the class of the test point 145 comma which one? 0. So this is what we called as query point, or also called which one? Test point. Query point which one? Test point. Okay, so now what we can gain algorithm from this query point or test point? We have to find out the distance to all the points in the data set. We have to find distance from this point to this point, this point to this point, this point to this point, this point, this point, and this point. We have to find out the distance from this test point to all the points in the data set. So here I am using what is called as Euclidean distance. Euclidean distance. What test point here? 145 comma 0 is the test point. So we have to calculating from 145, calculating distance from which one? 145 comma, this is test point, yes or not? So 145 comma 0 to 2, find out distance from what is the first point? 150 comma 0. So how we are calculating? Square root of 145 minus 150 whole square plus 0 minus 0 whole square. Then get the value some 5. Like that we are calculating 145 to 170 comma 0. 145 minus 170 whole square plus 0 minus 0 whole square square root. This is 25. Like this 145 comma 0 to 140 comma 0. Okay, then we get in distance is how much? 5. From again 145 to fourth point, 145 to fifth point, 145 comma 0 to sixth point. Like this we are calculating the distance from the test points to all the points in the data set. Now here I am given as some distance values. What is the distance value from 145 comma 0 to first point? It is a 5. Clear? Now what is the distance from test point to second point? It is 25. Clear? And the distance from test point to third point is how much? 5. Okay, and the distance from test point to fourth point is how much? Some 15 point, how much? 0 3. Clear? And the distance to fourth point is again 15.03. Clear? And the distance from test point to sixth point is 10.05. Clear? So now these are the distance values from test point to all the points in the data set. Here what is the value of k? Here what is the value of k? The value of k is how much? 3. What is the value of k here? Value of k is 3. Clear? So here value of k equal 3 means we have to choose k smallest points. So what is the smallest value? First smallest value? 5. Okay, this is the first smallest value. And what second smallest record? This one is second smallest record. Again, second smallest value is again 2. And next smallest value is 10.05. This is 3. Now we have to choose k smallest distance points. Okay. So first one is first record. This is the third record and sixth record. These are the three records having the smallest distances. Now we have to find out the class of these smallest distance points. What is the class of this point? Apple. What is the second smallest? What is the class of second smallest point? Apple. What is the class of the third smallest point? Orange. Okay, so this is apple. Next smallest point class is which one? Apple. Next smallest point class is orange. So majority contains to which class? Apple class. So 145 comma 0 is the test point. This test points belongs to which class? Apple class. This is the simplest algorithm, okay, compared to all the remaining machine learning algorithms. If we are knowing the distance method formula, we can easily find out the class of the given test point. Okay, likewise the KN algorithm works. Okay, here I can explain. Here I am not building any model. Clear? Simply I am finding the distance from test points to all the points in the data set. Okay, from that we are choosing the k smallest points. From the k smallest points, which points belongs to a majority class, then that is the class of the given test instance. That is the class of the given test instance. That's why the KN algorithm is called as a lazy learning algorithm. KN algorithm is called as which one? Lazy learning algorithm. Clear? This is another example you may also solving. Okay, that is here taken as iris data set. Okay, given as sepal length and sepal width. This is the class label. Okay, then find out the class of the 5.2 and 3.1. Here what we can do, finding the distance from this point to all the points. Okay, then take the value of k. Based upon that we have to find out. Here I am taking the value of k is 3. Okay, so k equal to 1 is it was a class. K equal to t is set as a class. If k equal to 5 also I am taken as set as a class only. Okay, so how we are applying previous data set, the similar we are applying for which one? This algorithm, this data set also. Here the point is when we are considering nearest neighbors. So less than 20 attributes per instance, then we are considering the KNN. A lot of training data, that may also be considering the which one? KNN algorithm. Now what are these are the advantages of KNN algorithm. Training is very fast, learn complex target functions, do not lose information. Why? Because we are finding the distance from test points to all the points in the data set. That's why there is no chance to lose the information. Okay. Now disadvantages. Okay. So slow at query time. That means need good indexing. That means we need to find out the distance from test points to all the points in the data set. That's why maybe a slow at query time. And irrelevant attribute may increase the distance of truly similar examples. That means here we are considering all the features. Okay, in that features, some features may be irrelevant features. Okay, so those irrelevant features may impacting on the final class of the test point. This is one of another drawback of which one? KNN algorithm. So if taken as the larger value of k, maybe that algorithm may be suffered with which one? Underfitting. If taken as a small value of k, okay, maybe that algorithm, okay, suffered with which one? Overfitting. That means choosing the value of k is also important factor in KNN algorithm. If you choosing the larger value of k, maybe that model suffered with underfitting. If the value of k is small, the model may be suffered with overfitting. So to overcome that problem, choosing the value is also a important factor in KNN algorithm. For choosing the value of k, we are using maybe some hyperparameter tuning techniques are there. By using that one, we have to find out the which one the best value of k. So how we are applying the KNN algorithm for regression? Clear? Same concept. Okay. Let us assume this is the test point. Let us assume. Okay. From the test point, these are the nearest or smallest distances. Okay. Here, what is the value of k here? The value of k is here how much? 3. So these are the three smallest distances, okay, from the test points to the all the data set. So if you are applying the KNN regression algorithm, simply we are find out the average. So what value of k here? 3. That's why we are choose three smallest distances. Then we are finding average 50 plus 55, okay, plus 51 by 3. What is the value we are getting? Okay, that is the final value of the given test instance. What is the value we are getting? 105, 106, sorry, 150 plus 6, that is 156. Okay, so 156 by 3. Okay, so we are getting how much? 50, 3 5 is there 15 and 3 to 6 52. This is the final value of the given test instance. As you know that in regression the class value must be a numeric value. So the class of the given test sample is how much? 52. That means in if you are applying the KNN for regression, clear, we are finding the k smallest distance values, then we have to find out the average of those k smallest